Okay, so what we're going to do is continue where we left off with the last vodcast talking about molar mass. And I want to look at the lithium sulfate first. So first of all, let's write the formula for lithium sulfate. I just want to go through this one more time a little slowly in case you either didn't watch the first vodcast or were a little shaky on it. If you want to calculate the molar mass for a compound, you need to take into account each element in the compound. So lithium sulfate has lithium, sulfur, and oxygen. You want to account for how many of each atom are in the compound. So there's 2 lithiums, 1 sulfur, and 4 oxygens. Then you're going to look on the periodic table. You're going to look up the molar mass of lithium. You'll see that it's 6.94, and I'm just going to round that to 7. Sulfur's molar mass off the periodic table is 32. So we're going to multiply the molar masses times the number of atoms in the molecule. And then oxygen has a molar mass of 16. So what we'll do, 2 times 7 is 14, 1 times 32 is 13, and then 4 times 16 is 64. So then just add up the individual molar masses, 14 plus 32 plus 64, and you're going to get 110. And again, the units are grams per mole. So for lithium sulfate, its molar mass is 110 grams per mole. All right, the 2 I want to point out here also are oxygen and hydrogen. Now remember, we talked about the diatomics in class, and I just want to emphasize the 7 diatomics are H2, N2, O2, F2, Br2, Cl2, and I2. And what letter do they form? What number do they form? They form a 7. There are 7 of them, and the point is when you write them by themselves and not in a compound, you write them as diatomics. So for example, if I said water is H2O, you might say, well, hold on, oxygen's diatomic, but there's only 1. It's 1 because it's part of water. Hydrogen is 1 plus, oxygen is 2 minus, so the formula is dictated by the charges. But when you write oxygen by itself, you write it as O2. Hydrogen the same way. So when you're adding up the molar mass of oxygen, it's 2 times 16, which is 32 grams per mole. However, if you were adding up the molar mass of water, it would be 2 times 1 plus 1 times 16, which is 18 grams per mole. Okay, you can do the calcium nitride, aluminum sulfide, and sulfur dioxide on your own. The formulas, though, are CaN2, aluminum sulfide, and sulfur dioxide. So looking on the periodic table, 3 times 40 plus 2 times 14, 2 times 27 plus 3 times 32, and 32 plus 2 times 16. So you can do those on your own and check your answers. Okay, let's take a look. Let's take a look now at what we do with these molar masses and compounds. So what we're going to do here is we're going to do conversions where we're converting using that concept. So the question says, what's the mass of 5.5 moles of sodium chloride? So we're looking for mass starting with moles of a compound. So let's start with 5.5 moles sodium chloride, and we want to convert to grams. So the way we do this is we use the molar mass from the periodic table. So if we were to add up our molar mass of sodium chloride, looking on the periodic table, it would be 23 plus 35, which gives us 58, and remember the units are grams per mole. So when you add up the molar mass of sodium chloride, you get 58 grams per mole, and since we're starting with moles, we want moles in the denominator, so we're going to write it as 58 grams per mole. That way the moles cancel and you're left with grams. So when you do the math here, 5.5 times 58, you get 319 grams of sodium chloride. Alright, let's take a look at the next one. You're trying to find moles, and you're starting with 140 grams of calcium chloride. So let's start with our 140 grams. Formula for calcium chloride is CaCl2. So we're going to set up our first conversion, and we want grams in the denominator because it's here in the numerator. So we're going to put grams calcium chloride. So again, you want to add up your molar mass of calcium chloride, and if you look on the periodic table, calcium is 40 plus 2 times 35.5, and we get 111 grams per mole of calcium chloride. So our grams cancel. We're left with moles, and that's what we're trying to find. So 140 divided by 111 gives us 1.26 moles of calcium chloride. Let's take a look at number 3. How many grams are there in 5.5 moles copper 2 bromide? So, whoops. Let's try that one more time. Let's start with 5.5 moles of copper 2 bromide, and let's convert that to grams. So we're starting with moles, so we want moles in the denominator. We're going to convert to grams. So if you look on the periodic table, copper is 63.55 plus 2 times bromine is 80, so we get 223.55 grams. So 233.55 grams of copper 2 bromide per mole. So that way our moles are going to cancel. We have grams. If we do the math there, we're going to get 1,229.5 grams of copper 2 bromide. Okay, let's take a look at the last 3 problems in your packet. We're looking for atoms starting with 45.6 grams of magnesium nitride. So let's start with our value, 45.6 grams. The formula for magnesium nitride, Mg3N2. And the first thing that we're going to do is make our conversion and put grams in the denominator, and we're going to go to moles of Mg3N2. So remember, it's 1 mole, and then add up the molar mass of magnesium nitride. 3 times 24 plus 2 times 14 is going to give you 100 grams. And again, we could write our magnesium nitride again here if we wanted to. That way our grams cancel, and now we have moles of magnesium nitride. Well, we're trying to find atoms. So our next conversion, you're going to put moles of Mg3N2 in the denominator, and 1 mole of that compound is 6.02 times 10 to the 23rd. Now that's a molecule. Now technically it's a formula unit, but we're going to call it a molecule for now. So it's that many molecules of Mg3N2 for every mole, but we want atoms. So we need one more conversion where we're going to say 1 molecule of Mg3N2 contains 5 atoms. So if we do the math here, 45.6 divided by 100 times 6.02 times 10 to the 23rd times 5, we're going to get 1.37, I'll write it up here, 1.37 times 10 to the 24th atoms. The common mistake that you're going to see here, people are going to forget that last conversion and they're going to stop at molecules. That's where knowing the difference between a molecule and an atom in a molecule is very important. Alright, let's take a look at the last two. We've got 4.5 times 10 to the 32nd molecules of water, and we want to convert that to grams. So let's do our first conversion. Molecules of water. Now if we're converting molecules, the only thing that we can go to is moles of water. And what we'll say is 1 mole of water contains 6.02 times 10 to the 23rd molecules of water. And then what we can do is our next conversion, 1 mole of water, you want to think to yourself, can we go from moles to grams? And sure, molar mass of water is 18. 2 times 1 plus 16 is 18 grams per mole. So our moles cancel, and we're left with grams. So 4.5 times 10 to the 32nd divided by 6.02 times 10 to the 23rd times 18 is going to give us 1.35 times 10 to the 10th grams. And again, knowing how to do scientific notation in your calculator is pretty important. Alright, let's take a look at the last one here. We've got 45.6 grams of oxygen atoms. And what we want to do is make oxygen molecules. And again, this is differentiating between atoms and molecules. So even though we said oxygen was diatomic, we're specifying 45.6 grams of oxygen atoms. So now, if we're going to find the molar mass, one oxygen atom is 16 grams. So it would be 16 grams per mole of oxygen atoms. I think I missed. Let me say that again. There are 16 grams of oxygen atoms in 1 mole of oxygen atoms. One atom doesn't weigh 16 grams. That would be the biggest atom ever. Okay, so now we can put moles of oxygen atoms in the denominator. Alright, let's walk through this problem one last time. We're starting with 45.6 grams of oxygen. And this is oxygen atoms. So there's 16 grams of oxygen atoms per mole of oxygen atoms. 1 mole of oxygen atoms contains 6.02 times 10 to the 23rd atoms of oxygen. And then what we can say is that there are 2 atoms of oxygen for every molecule of O2.